beautiful offices here at Greektown in Chicago at Manifold headquarters. I am so delighted to have a chance to spend an hour today with Mike Francis, who is a relatively new friend of mine, introduced to me from another friend down in Texas. And I met Mike when he was CEO of a company called Varesi, which was a consulting company that he had started. And he has left Varesi and he started Nano Shield, which we'll get into in just a minute. And, Mike's just one of those guys that, is an entrepreneur, has done a bunch of stuff in oil and gas, is a Texas A&M Aggie, which, the Aggies I know are a combination of humble and they get stuff done. And, they're not big believers in pontificating. They're more saint than Pope. Let's put it that way. If we're going to use that analogy. So it's great to have him here. I was just blown away by the technology that you're going to see today. And I was blown away along three dimensions. First of all, the Nano Shield stuff, as Mike will talk to, is amazing. It's got very, very high diffusion, very little transmission, so it allows you to coat things and to essentially temperature isolate, which is such an important part. And I hadn't really thought of it until I was talking to Mike about it's not just about saving energy or creating new alternative energy, but really how you manage temperature is a big, big, big deal. And his breakthrough technology really seems to help that a lot. Second thing is just the wonderful, early applications he'll talk a little bit about. And the third thing is just the, just the fact that I'm a big believer that it's going to take a group. I happen to do believe that climate change is happening. For those of you who are wondering, and it is man-made or person-made, person-caused. Anyway, my beliefs. And in that, we're going to need a symphony of innovations and entrepreneurs like Mike to really make a dent. Because when I go out and see my granddaughter Ginny, who's now 3.5, I don't want her, having to retreat to Montana to stay away from the water. Anyway, there we are. Mike, pleasure to have you here. Welcome.
Thanks for having me, John. We really appreciate it.
Excellent. Let me give you an idea of what we're going to go through in terms of our agenda here. So I gave you Mike's background. We're going to look at what's happening with nanotechnology and industrial processes, really some things about clean energy innovation, and intelligent digital mesh. We'll talk a little bit about, it's really kind of digital twin and how those relate to each other. If we have time, Mike will talk a little bit about the corporate startup partnerships. He's backed by a number of folks, Halliburton Labs, as well as some friends of ours over at Ecliptic Capital, where Mike Boyle and the crew down in Austin are doing some fantastic long-term investing with an evergreen fund. And then if we have time at the very end, we'll get into some of the important lessons of entrepreneurship, because Mike has been on both sides of that a number of times, both as a consultant to or inside large corporations and now being an entrepreneur. So we'll get at that. Mike, anything we should add or change on that agenda?
No, it looks good to me. Thanks, John.
All righty. So please, folks, over on the right-hand side of the screen, we see your chat stuff. And if please feel free to tell us where you're coming in from, as well as if you have any questions, we'll try to work them in to the conversation. I'll keep an eye on the chat. And then the other thing to know is at the end of this will be available to you, because we believe in Creative Commons sharing this kind of stuff. And you can reuse the content as long as you just kind of note where it came from. So if you're sparked as you do this to, gee, so-and-so should actually see this stuff, we'll have that available for you as well. Chat away. Just want to talk about a fundamental theme we have running through all of this, which is that as we get more digital description of everything, that allows for more and more computability of reality. I think the Nano Shield product is going to allow us to have all kinds of control of temperature, and then we'll be able to monitor that and how we model and think about everything from, your Yeti coffee cup all the way through, a petroleum refining plant. I think it's going to change. So it's pretty interesting times in terms of what we're getting into. Why don't I stop here? And I know, Mike, these things. Why don't you start us off with, how'd you get into this? And, and I know you're a very kind of purpose-driven guy as well as commercial. So, have at it.
Yeah. Thanks again for having us, John. So we're Nanotech, and we developed a new particle called Nano Shield. A little bit about myself. So I was in the corporate world for greater than 10 years, and was in a lot of different areas, but really focused on innovation and new product development and bringing technologies to the market. So I had the opportunity to work for two great Fortune 500 companies and ran some P&Ls, operations, and some strategy work over the course of my corporate career. And in 2014, I had this itch, and I don't really know how to describe it. I just knew that I wanted to do something bigger than I was doing. And I kind of felt the weight of the world on me at that time. I'll never forget the moment. I was sitting in my office thinking about at that time my two kids at home, my benefits, consistent paycheck, and I knew I was never going to be able to leave it. And at that exact moment, my wife of almost 16 years now sent me a text message and said, "I support you. Go do it." And so that text message really changed our lives. That night, I went home, was holding my about 1-year-old daughter in my hands late at night, and I remember looking at her face, and I couldn't recognize her, and it just destroyed me. I didn't want to be the dad that wasn't there. So very next day, I resigned, and didn't really have much of a plan. I just knew that I had to do something. So over the course of 2014 through now, I've had 3 different companies, Nanotech being the latest company where I've been focusing my time for the last 2 years. The way I came across it was I saw a very early version of the technology, and our now CTO had his hand coated in the tech, which we don't do anymore. But he had an oxy cutter placed to his hand, and nothing was happening.
And for those, an oxy cutter is a blowtorch, right?
Yep, and it cuts through steel. So at that moment, my now other partner, I looked at him and I said, "Look, I'm going to quit what I'm doing. You're going to quit what you're doing. We're going to go find some money, and we're going to figure out how we scale this thing." And that's kind of how we started. So we started out of a garage here in Houston, Texas. We were, curing our product in our home ovens and barbecue grills. We were crushing it using our F-150s. We would blend it all together with my old beer tanks. And luckily enough, we were the first startup to join Halliburton Labs, which is a clean energy accelerator. Uh-huh. And shortly after that, we were, funded by Ecliptic Capital out of Austin, Texas. And so they've been, instead of using our own money and our own chicken nugget budgets for our kids, we were able to really grow this thing in a great way. So that's kind of the origin story of how we all started.
That's amazing. Yeah, well, let's talk about the need a little bit in terms of kind of what's happening with. I mean, we have this the slide up here about from even last year in 2021, 70 to 90 billion. Never mind the human toll and the ecological toll on animals and the landscape and so forth. I mean, just amazing. And now we've seen even again the 2022 season is even worse, and it's global. I mean, it's got to be a huge thing that you guys could make a difference in.
Yeah, it's I happen to be a steward of this technology. The technology itself, there's really nothing like it. And one of our beachhead markets are fire-prone areas. So of course, we're working with the large, utility pole companies and infrastructure companies in the fire-prone areas, both coating different structures as well as embedding our particle into a lot of different resins and media. So what really drives us is certainly the prevention of infrastructure damage. Yep. You're losing billions and billions of dollars every year. But even more important to us, we work with private individuals, vineyards. It's the loss of their personal property that really kind of tugs at our heartstrings, as well as saving lives. People die in these things as well. So that's certainly a beachhead for us, and we're very, very heavily working in those fire prone states.
Yes, absolutely. And then, this we have fire prevention there, and then we have this whole notion on the renewables in terms of I don't know why that keeps going back, but that gives us going to have more and more renewable energy, and you play a role in that as well. And then, sorry, let me get out of here. Let me go over. Would you like me to start up the video here so you can give folks an idea of what we're looking at in terms of the technology?
Yeah, and as you play it, I'll just kind of go through on how it works and what makes it unique.
Okay, here we go. Ready? Egg coated with 2 millimeters of Nano Shield. And just as we get started, Mike, when it's coated with 2 millimeters of Nano Shield, did you just mix it with, paint or Vaseline, or what? How'd you get started on that one?
Yeah, not Vaseline, but definitely paint. So yeah, so the way it works is we have a particle, and the particle really is a platform for fireproofing and reducing energy consumption. So the way that it works is once we embed our particle into a media, so that media could be paints, it could be polymers, epoxies. We sell a water-based acrylic coating. Once it's embedded, that's where the real magic starts to happen.
Mm-hmm.
So we have two properties that are very unique when combined with each other.
Yes.
One is we have a third-party, lab test that says we have a perfect emissivity. So emissivity is on a scale of 0 to 1. We happen to be one of the only coatings, or the only coating we know of, that emits 100% of the heat away. It absorbs and emits it away. So that's one property. And then the second property is low thermal conductivity. So thermal conductivity is simply the resistance of heat through a surface area. And we have a lower thermal conductivity than what even NASA uses on their reentry programs.
Wow.
So those two properties in conjunction with each other allow for extreme fireproofing. So we can fireproof to about 1800 degrees Celsius at minimal thickness. There's no chemical reaction that happens. So the reason that that's important is there's no smoke, no toxicity. It's a very environmentally friendly product. And it's really the particle. So we're just scratching the surface of where we're going. So the particle itself is very adaptable to multiple things that can be embedded into.
So what we just saw there was just a regular egg coated with 2 millimeters. The other eggs just were destroyed by the heat, and your technology just allowed for the egg to be perfectly raw still, right?
Yeah, so I shoot those videos in the backyard with my 3 kids. So my wife and I would get a glass of wine, and we'll fire things up. And typically the neighbors won't call the fire department on us, although they have complained a couple times.
So, I can see it now. You're going to coat one of your kids and chase around the backyard with a blowtorch, and then the neighbors are really going to go nuts.
Yeah, luckily the HOA hasn't found out about it yet. Otherwise, we'd be in big trouble. But they're also great memories. I love getting my kids involved in the science aspect of what we do.
That's fantastic. And Mike, who actually invented the molecule?
Yeah, so it clearly wasn't me. So we have a brilliant PhD material scientist. 1% of the world is genius, right? And I feel like we've discovered one of those 1%. When it comes to new materials, he is truly a savant. So we keep him, he's great at coming up with new materials. He's not as good at running a business. So
sure.
We complement each other, really well. So he stays in the laboratory, and we feed him pizzas underneath the door there. And he comes up with just these amazing solutions in a very rapid amount of time.
And what's his name?
So we lovingly call him Dr. C, and his name is Claudine.
Claudine?
Claudine, yes.
Lovely. And is he appointed somewhere? Is he like in one of the Texas schools, or?
No, so he's a full-time employee of NanoTech. So he's our chief technology officer. So he develops things for us all day, every day.
Wonderful. That's great. Well, tell us a bit about what are some of the challenges you face when it comes both nationally and globally, as you think about getting out to the fireproofing, application that you've mentioned?
Right. So as probably everybody knows, introducing new technology is always a challenge, especially when you're dealing with new materials. And then you
Sure.
take it another level, you're not only dealing with a new to the world particle and material, you're dealing with a material that is intended to save infrastructure and save lives.
Right.
So with that, there's a lot of challenges in terms of how long it takes from introduction to actually making money.
Mm-hmm.
And those are done through, a lot of those certifications that we go through.
Yes.
So it's pretty cool. So we've spent Ecliptic's money. We think wisely by investing in those certifications. So we're able to achieve multiple hour ratings on lots and lots of different assemblies. That's called Astm E119. We've passed multiple Navy specifications. We've passed all the wildfire tests in California.
Yes.
So it's not just backyard videos, although those are what catch people's eye.
Sure.
We truly are certified to prevent fires in a really big way.
So, Mike, just for those of us, including me, that don't know what an ASTM certification is, like what is it that that it can take this amount of heat for this amount of time, with this, or how do I think about it?
Yeah, so it's to show the world that what we say we are producing is actually produced in the manner that we say it's going to be delivered, as well as it performs in the way that it needs to perform. So the ASTMs are, if you get a 1 hour rating, that's saying that I can prevent a fire from penetrating the wall or the ceiling or the floor or what have you for a particular amount of time. So we've even achieved almost 2 hour ratings on OSB, which is just wood. But prior to that, the longest rating that we know of was about 30 minutes. So we've increased it from about 30 minutes to more than an hour and a half. And why that's significant is it gives people time. So
Yes.
time is everything. And as long as we stay below that 1800 degrees Celsius, our product will continue to perform and continue to last. So it really is a step change in how fireproofing is done.
Fascinating. So first step is, no pun intended, first step of the step change is certification. And so that your claims, and just like with a drug or something like that, your claims are validated by the proper institutions. And then next phase is?
Yep. Then it's adoption, right? So building, and we're in that process right now. So we are in the process of closing and raising a Series A. And the reason that we need that is, one, we need to produce enough raw material to get it out. So we work with more than 40 Fortune 500 companies right now. All of the certification and the testing has been completed over the last year to 18 months.
Yes.
Now it's adoption. So if you're working with a big chemical company, they still have to work to get to their end customers. And when you think about the entire ecosystem, you're not dealing with one piece of the supply chain.
Yes.
You have to take an ecosystem approach. And NanoTech loves to be connected to the customer because we want to do two things. One, we want to lead in technology. And two, and I think it's just as important as technology leadership, is the customer experience.
Yes.
So we're taking a very methodical approach to make sure that we don't lose that voice of the customer at the very end. And that voice of the customer will then inform how we develop new technologies that are truly breakthrough.
That's cool. Had a question here from Patrick Amante about, is a typical fire, commercial or house fire, 1800 degrees or less?
Yeah, so carbon-based fires burn, they have, top temperature around 1200 degrees Celsius.
I see.
So what's really wild about our technology is actually once it reaches thermal equilibrium, meaning, hey, it's not going to go above 1200 degrees. That's kind of where the temperature stays. Our technology will actually drop in temperature. So once it reaches thermal equilibrium, the emittance of the heat away, the molecular vibration that actually happens within the particles that we have, will cause the substrate, meaning whatever the coating is on top of,
Yes.
to reduce the temperature. So we can actually last. We've done 24-hour tests, staying below that 1800 degrees Celsius,
Wow.
and the surface does not burn, which is a huge step change in what is out there today.
Well, why is the wood claim so low then, in terms of just getting it over an hour as opposed to a day?
Yep. So there's other things involved. So it's not just the fire. So the test that I mentioned is a very intense test. And what happens is a lot of times you'll have delamination with certain substrates. So once there's delamination that occurs or a crack occurs, because let's say the wood expands or the drywall expands. So once you have that the expansion that happens, there's penetrations that can happen for the fire to go through. So it's our job to make the product either more or less flexible based on the assembly that we're going on. Yeah. So it's if everything else was equal, like if you just had a flame trying to penetrate, it's not going to penetrate. When you have other things like vibration or water that actually hits it or anything else, then you can have those penetrations that occur. And that's part of our challenge is, how do we develop coating systems that deal with those secondary and tertiary effects?
Sure. Yeah, that's amazing. So it's so interesting. One of the questions I had when I was, I've had so much fun talking to friends and relatives and so forth about your technology. One of the questions that folks had is that I have a particularly skeptical dear friend who's also an Aggie. He goes, yeah. He goes, okay, what's the catch? He goes, what's the downside? Does it poison people? Does it do this? Does it do that? I mean, we're all walking around with carbon nanotubes in our lungs from catalytic converters, from the nanotechnology there. Kind of like, how do you think about the downside issues and how do you manage them?
So one of the blessings about we are physically located in the Halliburton facility. So they've been gracious enough to give us a little over 10,000 square feet.
Wow.
And we produce our product out of there. If anybody knows oil and gas and Halliburton in particular, safety is a given. So it's number one. So I would make the argument that other than chemical companies, there's very few companies that take safety more important than Halliburton. Yes. And so very early on, and we hated it at the time. So remember, we came from a garage,
right,
where we have, respirators on and the HOAs driving by and seeing what's going on, and there's powder going everywhere. And
I love the fact you use the F-150 as a grinder. It's like, I want to see that on the next ad. If you need to crush your nanotechnology, buy the F-150.
Exactly. So that's where we're coming from. We're drinking beer in the driveway, and it was a shock. It was an absolute shock to go from the garage, the true garage, to a Fortune 500 company where safety is number one.
Yeah,
it's a given. And so early on, they made us go through all of the HSE issues, right? So every piece of equipment that we have, we got to make sure our people are safe. So we have a risk assessment. We have a standard operating procedure.
Right.
Every material that we bring in on campus has to be approved by their HSE. And it's a process to get in. So we hated it at the time. It's proven to be just a great asset for us because now we can say with confidence, our product has no volatile organic compounds. It's not you can't inhale it once it's actually in the media. There's no crystalline in it. There's no asbestos in it. So we've done all of those environmental studies because we were forced to do it to have a footprint in the Halliburton facility. I breathe it and get it in my beard and all over my body every day. And there's no VOCs whatsoever. Halliburton can paint using traditional paint less than we can actually spray our product. So paint is more harmful than what we have.
Wow. Yeah. And what's a VOC, Mike?
That's a volatile organic compound. So our particle itself is all inorganic. which has a lot of positives to it, meaning it'll last forever, or not forever, but it'll last a very, very long time as an inorganic compound. Think about sand. It's basically glorified sand or silica that we're dealing with here.
Sure. That's funny what you say about the safety thing. I remember I was a young professor and I was going down to DuPont in Delaware to do a presentation. And it was the first time ever I experienced the chemical company, focus on safety, because the very first thing, right before the executive introduced me to do the talk, is he went through the safety procedures. Here's here are the exits. Here's what you need to do. Here's who you need to call if there's a problem. It was amazing. And we were just in a hotel, right? And it's just embedded in their culture. That's wonderful. Brett Peterson is asking, can you embed this stuff in 3D printing materials?
Yeah, so you can. So once you embed, so our particle is obviously a solid. The solid, it starts to activate between 5 and 10% by weight. So that's the loading. So let's say you have, for simplicity, a can of paint that weighs 1 pound. 5% of our particle will start to have an effect on that can of paint.
Gotcha.
The trick there is you have to work with how much viscosity is acceptable. How much does it change the mechanical properties?
Yes.
So for example, we've successfully been incorporated into cement. When we're incorporated into cement, we reduce the thermal conductivity, which means we increase the insulation of the cement by about 10 times.
Wow.
So that's great, but does it change mechanical properties? Does it change viscosity?
Right.
Those are the secondary and tertiary things that you have to look at, but we work well in a lot of resin systems, which is why, Brett, to your point, it's a platform. The particle is a platform. It's not a coating. It's truly a new particle which can be incorporated into lots of systems and construction material.
Boy, now if you have to be 5 to 10% of weight, especially when you start talking about something like concrete, that is a whole lot of nanoparticles.
It's so the way we get around it is we do not go to the nano level when we incorporate it into things like cement. So we'll stay at about the 4 micron level, which is not even close to a nanoparticle. Now, the makeup of our particle includes dispersed nanoparticles that go into our 4 micron particle. So the final product that, say, like a Cemex or a cement company gets would be a 4 micron particle that is made up of other materials, including nanoparticles that are dispersed.
Fascinating. So what are the kind of implications and results do you think widespread adoption would have in something like energy consumption, things like that, when you do this kind of fireproofing?
Why don't we bring up that one other video and I'll show how.
Coming up.
Yeah, I'll show that we're not just in the fireproofing market. We are also in the thermal isolation market.
Gotcha. Alrighty, ready? Here we go.
Yep. So you have to excuse the cheesy music. I have no taste in music, and at the time when I made these, we didn't have money to pay somebody. So
there you go.
So our coating is not just fireproofing. So think about fireproofing as extreme thermal isolation.
Okay.
Traditional insulation is creating space or voids to dissipate the heat, or using mass to dissipate the heat. Ours works by emitting the heat away, so that emissivity, and then the low thermal conductivity. Mm-hmm. So there is a whole burgeoning space. I think it's going to be one of the fastest growing spaces over the next 10 years, which is the cool architecture space. So mm-hmm. Cool architecture just means, how do we reduce energy consumption with the building materials that we have at our hands today?
Sure.
So our coating, and one of our beachhead markets, is actually coating on top of an industrial or commercial roofs. When we coat on top of the roof, and you only need about 1 millimeter to do this. The effect of it is the emissivity emits the heat away, and then the low thermal conductivity stops the heat transfer. The result is reduction in overall heat in the building, which reduces the energy consumption. So, for example, we coated a roof last week here in Houston.
Mm-hmm.
It was about 95 degrees outside. Our coated side was also about 95, 96 degrees. And then our uncoated side was 165 degrees.
Wow.
And so what's happening is very little heat is transferring through the roof, which is a major area of where energy is lost. And because of that, we're able to reduce HVAC consumption in many cases by up to 50%.
Oh
So
my
the
goodness.
space that we play in the energy transition is we're agnostic to what form of energy is used. Our goal is to reduce the overall consumption of the energy as a whole to make all forms of energy viable in the future. So if we were on, let's say a tenth of the roofs here in Houston, we could actually calculate how much energy is saved as a whole, and in turn, how much carbon is reduced building by building. So that's been a beachhead market for us. And I don't want to pat ourselves on the back because this is not me, this is our team, but we are by far the best roof coating that is in the market.
Awesome. Wow. That's so much fun. I want to get some. I just had a new roof put on my house here in Chicago, and it's my house is actually pretty energy efficient. 1904, 3 courses of brick, you know what I mean, kind of thing. And then, I buy wind from the thing, and we have some, from the utility wind power, and then we've got some heat exchangers. But if I could coat the roof, that'd be awesome. Do you have any idea, like at scale? I mean, is it going to cost me like $20,000 to do that on my roof, or like 2,000 or 200?
We're trying the biggest thing with new technology. You can have the coolest technology on the planet, but if it doesn't meet the technical commercial envelope, meaning consumers are not going to pay for it, it's never going to happen.
Sure.
Beauty of our technology is we can scale it up in a meaningful way with a high return on invested capital for us. Right. That means that we can sell it to the end consumer for about $1.50 to $2 per square foot. So you can do the calculation on your roof, and you can say, hey, if I have a 2,000 square foot roof, it's going to cost me $4,000.
Right.
We can actually calculate how much typical energy you would save, and that payback, could in many cases could be as short as 18 months, 2 years. So you can actually have roofs that pay for themselves by the reduction in energy use.
That's amazing. Cool. How about on the Jim Suriello is asking, who works at CSL Bearing, one of the global leaders in, among other things, plasma technologies, and they're very interested in cold chain. How is this used in cold chain? Because there's tons of stuff. You remember back to the early COVID vaccines. A lot of it was really one of the big logistical challenges was to make sure that it stayed cold enough, right? For the Moderna one in particular, if I remember right. So what does that look like?
Yep, great question. So as long as there is a large temperature differential between the ambient and whatever's inside or outside, our technology works. We do better with heat, but we also work on the cold end of the spectrum as well. So for example, the cases that we have right now are with beer companies. So beer companies, they have these fermenters that have a glycol jacket on the outside. They pump glycol to keep the beer cold.
Right.
With our coating on the outside, we've been able to reduce the amount of glycol that's been used by about 40%.
Wow.
So we're headed to California here in 2 weeks to work with the largest independent craft brewer to coat all of their tanks as well. So we don't have a ton of use cases on it, but the ones that I know best, because I like beer, are the ones that we've done with insulating the glycol jackets for fermentation. Now, our coating itself will go down to about -30 degrees, I believe. After that, we have to use different materials.
Celsius or Fahrenheit?
Fahrenheit, yeah. So we can be embedded into like a silicone or another. Again, it's a platform. The particle is a platform, much like graphene. The particle is a platform to do really cool things in other media.
So it's the kind of thing that, let's say, just for a thought experiment. So I got an Igloo cooler or Yeti or whatever, right? I put your stuff in the plastic that the thing is made in, right? So that cost me whatever, let's say $50 a cooler or something like that for a regular size cooler, $100, whatever. And then that bad boy, let's say I'm transporting, the Moderna vaccine, which I think was 50 minus 50, so it's going to have a hard time there because that's below your threshold. But if I'm transporting something that needs to be frozen, let's say Fahrenheit frozen, it then will, whatever my normal degradation cycle was for what's keeping it cold, that extends it by I imagine it depends on the different variables, but let's say I'm trying to keep it frozen. If my old technology would keep it for a day, this would keep it for like a week or 2 days, or you don't know yet.
We don't know yet, but so our coating goes down to about -30, but other coatings will go down much further. Our particle itself, will continue to last in very, very extreme temperatures. So it's less about the coating and it's more about choosing the right coating, if that makes sense.
Gotcha. But you would expect a pretty material extension of time given the temperature differential and whatever's keeping the thing of interest cold.
Yeah, the only test that we've done, and it's not scientific at all, is we coated a beer keg, and my partner and I sat on his back porch, and we had one that was coated and one that was not coated, and then we took measurements kind of every 10 minutes or so.
Measurements.
Yeah,
right.
But the measurements became less and less accurate, as you can imagine, as the day went on.
But all kidding aside, roughly so like the regular keg get warm in what, like 4 hours or something, and the other one
it extended the life by about 3 times.
About 3 times. That's awesome. There you go. Yeah, another time over drinks or dinner, I'll tell you about my brother Skip was a emergency room physician, and one of the, I don't know if it's still true, one of the things that the beer makers union had in Rhode Island where he was working is that they had beer every 10 feet. No, every 30 feet they had to have a spigot, and they had to have enough spigots that during their breaks they could have a beer. And he said the kind of industrial accidents that came out of that place were just horrific. But you can imagine, right? But that was part of the contract, because we needed access to beer on a regular basis, right? Anyway, I'm sure it's not the same now. But also had a question about transparency. This. Do you have a molecule that could be used on windows and things like that, or not yet?
We do. We've managed to incorporate our particle into a clear coat. Can't talk about it too much because we're still filing some IP for that specific application. But how it will be coming out in the next year for sure. Once we get the proper IP filed on that one, we'll do another big marketing campaign and push so that you can see what we're up to. But Windows, it definitely works. And there's even bigger markets than Windows that we've already tested on they look very, very promising for us.
That's neat. And you can see the next question here by Patrick on when do you coat and when do you incorporate?
I love coding because it's done and it generates cash flow for me immediately.
Right.
The particle, in trying to determine do you put it into a resin system, a new resin system, or a fiberglass pipe, is all based on the mechanical properties. So, for example, if it's like a geothermal application, there's no way that a coating is going to withstand geothermal conditions. And so we incorporate our particle into the epoxies. So we take a strategic approach to it. Clearly we need to make returns soon, but there's, the good thing about Ecliptic is they are an evergreen fund. And so they allow us to look at longer term R&D projects. So just on average, we probably have about 15 or so R&D projects going at the same time for large customers with large volumes. So we'll never do it for, a small amount of volume, but we always love to do it for larger volumes.
Gotcha. And I know you and I have talked a little bit about this because, full disclosure for our audience, I'm on the board of advisory board of a company called Gemline, $100 million promotional products company. Actually, more than that now because the CEO is an amazing entrepreneur. Anyway, he managed to grow during COVID, which is another whole story. If you know the promotional products business. Anyway, are you also thinking about licensing out categories like, drinkware or coolers or things like that? Because as you and I have talked, I'm ready for my, I carry around one of these things. I'm ready for this thing to keep my coffee, hot for 17 days or something cold for 2 weeks.
Yeah, so you probably don't want to hear this from the CEO of the company, but we're still kind of figuring out the strategy of how we balance the protection of IP with the longing to generate cash flow through licensing agreements, etc.
Sure.
So we're taking more of a methodical and slower approach to licensing because we want to make sure that the decision that we make is going to make the company last much longer than, the current team is in charge. So we haven't stacked hands on what that looks like. So right now what we do is we test with the companies, we share how things work, and then that final product, that comes out of it, we share IP back and forth.
Yes.
So whether or not we license or not is still up for discussion. But we love when companies incorporate our particle into what they're doing. And if there's IP that comes out of that, whether it's the process or whatnot, we love that because then it secures our position as a critical component in the larger company's supply chain.
Yeah. I mean, obviously you wouldn't want to, you don't want to have the General Dynamics problem, which is, if you look at the General Dynamics drone, which costs about $9 to $10 million, and you look at the Chinese competitor, they look an awful lot alike. And the Chinese competitor's under 1 million. So anyway, and not to say it's just the Chinese. I mean, actually back in Massachusetts, where I'm from originally, living out in Chicago now, the main street in Waltham, Mass is Moody Street. And the engineer Moody was the guy who supposedly stole the IP from the Brits for the shuttlecock loom, which made Massachusetts manufacturing at the time. So there you go. What was it? What was it? Was it Mark Twain or Balzac that said, steal a fortune, the world will conspire to make it respectable. So Mr. Moody is a hero in Waltham, Mass. So there you go.
That's right.
Hey, what kind of, if any, public-private partnerships do you think could help accelerate your technological development?
So we have a government affairs liaison that is helping us work with both the decision makers. So I was lucky enough to meet with the federal senator out of Nevada a couple weeks ago, as well as the Department of Energy and DoD. So we're exploring those partnerships. We think we can have quite an impact on the DOE side. And we, selfishly, we like to set the regulations that truly protect and save lives. Like we don't want to just pass a test. We want to go above and beyond that. So we work with those government people to say, hey, this is what can be done. This is the implications for how we will protect that infrastructure, et cetera. Let's set the regulations at a standard that's not just checking a box, but it's truly doing good for the world. Same on the energy side. So we're very, very careful about which claims that we make on the energy side. We're still figuring it out, and having a partnership either with a university that can establish new energy metrics for us, whether it's a blockchain company that's saying this is the before and this is the after, let's believe in this, or whether it's a government affairs arm, we love those public-private partnerships.
Fascinating. Any applications in the winery industry?
Yeah, we're fortunate enough to be able to go out to Napa quite a bit. So we work with some of the larger vineyards and whatnot in the California area. So I'll kind of break it out into two spots that we can help. One is, we fireproof vineyards. So within California, the insurance rates are incredible. So they're spending millions and millions of dollars every year, and they've gotten to a point where many of the vineyards are not insurable. With our technology, what we're trying to do is work through the insurance companies to say, if you have this on your building, on your structure, which some of these structures are, multi-million dollar structures, the chances that you would have a huge payout get reduced. So we are very, very much in that space in Napa. It's one of my favorite places to work. We had a job in the prison, the same time that we had a job at Napa.
Yes.
I took the job in Napa and let somebody else, take the job in the prison. But yes, and also anywhere where they're keeping heat out or keeping cold in the fermentation process, that's where we can help as well.
Sure. Yeah, I don't think I've introduced you to a friend of mine, John Mccomber, who teaches at Harvard Business School, and he has a course on how do you finance mitigation technologies for climate change. And like there's some folks who've done things like bought houses in parts of Florida or the Carolinas that are uninsurable. They do a series of upgrades, and then they become insurable. So it might be a interesting connection. I'm really interested as well. How about you when I asked you the government stuff, you didn't talk much about the government as a buyer, right, of stuff. But if you look at the history of our industrial policy in the U.S., which we never call industrial policy, but it is, a lot of times the government is an early buyer to get you down the price, the cost curve in terms of volumes and getting the manufacturing right and so forth. I've had the good fortune to speak with and talk and to do some events with a guy by the name of Mike Crow, who is the president of Arizona State University, which is doing fantastic work around lots of things, including trying to decrease the heat sink nature of these desert cities, especially Phoenix and so forth, which I think is approaching not going under 100 degrees day or night from April through October. So I don't know, is there any kind of application there whether you coat the roads or do other things? Obviously the houses and so forth, you've talked about houses and industrial sites and so forth.
Yeah, so there's a couple areas. One, we are working with the U.S. Navy. So we've managed to pass. So the worst place that you can have a fire is, where you're on a boat or you're on an offshore oil and gas rig or something of that nature.
I would argue a spacecraft, but after a spacecraft, I would say.
After spacecraft, that you're 100% right. After spacecraft. Yeah, so the issue there is, they use a lot of steel, they use a lot of copper. They would love to use composite materials, but composite materials burn. Right. And they generate a lot of smoke and they have a lot of flame. And so where we play both for the U.S. Navy as well as offshore oil and gas is you can actually replace metallics, which corrode. Oil and gas space, you have to replace them every 3 years.
Sure.
Very expensive, very heavy. You can actually use our material because it doesn't produce smoke. It deals with the long-term, like a long-term pool fire. And you can slowly start to replace those steel structures with composites. And that's exactly what, the Navy is looking at us for, is how do we replace certain steel or copper piping with composites or plastics that are much, much, much cheaper, but they have the safety effect of having a metal structure. And then the second place, is really this whole idea of this urban warming, right? So the asphalt that we have everywhere, just buildings everywhere. That's why it could be such a big game changer if we incorporate our particle into the cementitious materials, there's no change in process. You're still laying the asphalt, you're still laying the stucco, you're still laying the cement. The change is that final product is less thermally conductive and transfers less heat into those urban environments. And we're definitely looking at that. We also have a super white paint that is going on, that's potentially going on top of these urban areas to reduce that heating effect.
Amazing. Fascinating. What do you think are some of the, I know that as an entrepreneur, you have to focus, right? And execute. So what are the areas that are kind of coming along that might be interesting? You mentioned that you can talk about, right? That you mentioned, clear coatings, which obviously opens up tons of, potential markets and so forth. What are some of the other ones that you think would be interesting behind, again, within all the, constraints of not disclosing strategic issues?
Yeah, our challenge, and it's been probably, I don't want to call it a mistake because it's been very beneficial for us. But if I were coaching myself, I would tell me not to do what I've done, if that makes sense.
Okay, well, what about what you've done? Well,
yeah, so
obviously some of the stuff you've done, you would still do, but what's the parts you wouldn't do?
yes. So when we first started, we were still figuring out what is this thing that we have.
Yep.
And if we would have chosen just a couple markets to go after early on,
Yes,
we would not know the true potential of what we had. So we took kind of like a minimal viable product approach where we said no to almost nothing, right? So it could be a tiny little project, but we wanted to learn. We wanted to figure out, does it work? Does it not work? And we did that for about a year. It's great. So I view that kind of first year stage as, discovering who you are, finding product market fit, learning which areas are going to have technology adoption and which are not. And now the theme of the next 18 months is absolute laser focus. So we've taken up a very broad approach, and now we're laser focused on just a couple beachheads. So the two beachheads that we're focused on are one, the cool architecture market. Our product does the absolute best that's out there, and we already can't even keep up with demand. What's happening in the roofing section? Very few. There's lower regulations, and we can generate cash flow now. And then the second beachhead market that we're going after is the fire-prone states and the infrastructure surrounding that. The reason that we're doing that is, one, the size of the prize is absolutely enormous, and then two, we've already passed the test and we have a really good shot at being the fireproofing standard for those fireproofing states. So we chose two beachheads. One is on the fireproofing side, and then the second is on the energy reduction side.
On the fireproofing side, are you partnering with insurance companies?
We are. Not every insurance company is interested in lowering rates and having new technology adoption, but we found a handful that absolutely want to have and introduce new technologies to their customers to reduce the overall burden, the overall financial burden of the insurance company. So we've identified 3 or 4 of those that we are working with.
Yeah, well, the fact that, as you're saying before, that if you can collapse the tail, the really catastrophic, obviously you're enough of a statistician, right? That's where a lot of the risk comes in, right? If you can, and hence, you average that out and cost everybody. We all pay that tax, right? So,
yeah.
But yeah, fascinating. Hey, one of the things that I know we're coming up, we got about 6 more minutes here, and I'm gonna have to keep about 3 minutes to close and talk about the next one. What's the biggest thing that you have learned about, because you're, you had that epiphanic moment where your wife said, "Look, I got you, go for it." What's the biggest thing you've learned about being a category creator? Because that's usually really hard.
So I think every answer would be different for other people. My answer is it all comes down to people and culture. The talents I have are arm wrestling, drinking beer, and growing a giant beard. I need to fill the organization out with highly technical, but also people that can deal with customers. And having that mosaic of talent that complements each other as we go from a 20-person organization to a 50 to a 100-person organization. I don't want to lose the magic of the garage and the magic of the mission as we scale. So this technology is going to be adopted. You could put anybody in this seat and have the technology adopted. What I am most concerned about and what keeps me up at night is getting the right people to continue to have the passion for new technology, the passion for customer, and the passion for doing something good. When we have that in place, the people, the culture, and the technology, I have no doubt in my mind that this thing is going to be a rocket ship. And maybe somebody else has a different answer, but that is what I truly feel and what I'm passionate about.
Well, thank you, Mike. That's such a great answer. I so much hate to not have another 3 hours to just keep going on this thing, and maybe you can come back in a bit and update us as your progress and so forth. And you and I have a few things to follow up on in terms of opportunities that might be on your vector of focus, and I'm sure there's some folks in our audience who might be interested in getting in touch around ways to accelerate your wonderful journey here. Well, thanks so much, Mike. Continue to have great success, and it's such a blast to be with someone who's so capable and so humble and working on such an important thing.
Thank you for having me. Final thought there is every startup looks for their tailwind. Anytime we get identified to do something like this, we don't take it for granted, and it's a tailwind. So thank you, John, and thank you, Manifold team, for hosting us.
Our pleasure. Thank you. All right, let me. There are everyday uses of nanotechnology. I'm going to skip over the rest of the story here as we're running short on time. Let me give you a couple of things. The content we have here is shareable. We believe in creating a public good with our work here to the extent people want to do it. And if this has had an impact or something that you would want to bring back to your organization, we'll do our best to facilitate that conversation with Mike or other folks around these topics that we deal with. So we're very much about spreading the knowledge. Next month, we're going to have the man I mentioned before, who was John Mccomber. John and I go way back. We went to business school together. I wrote a case on a company that he was running at the time when I was a professor. And he's just a great guy. He is, John's an interesting combination of fantastic teacher and absolutely, if I were trying to pass off something or trying to tell a story to somebody that wasn't like 1,000% true, John is the last guy in the world I would want to put it in front of. He calls BS on just about everything, and he's super humble and super well informed. And as I say, John teaches a course at Harvard Business School in the area of how to deal with mitigation technologies in the context of climate change and some of the changes that we're seeing. So it's fantastic. It's very practical. It's hopeful. And John is very thoughtful because there's all kinds of structures, capital, and activities that I believe need to be unleashed. So we'll be talking about some of the interesting things that he's working on in terms of mitigation strategies, so somebody can do something, not just wring your hands, over the fact that we're seeing these changes happen to our ecology. So as I mentioned, we do all this under a Creative Commons license. The one that we use here is share and share alike. So feel free to to take this material and reuse it if there are any ideas or things in here. And all you need to do is, you don't have to ask our permission. Just please tell folks where you got it from, and you'll be within the copyleft regime that we believe in for this material. So thanks, everybody. Thanks again, Mike, and look forward to seeing everybody next month.